All right, so we're going to begin our chemical reactions unit. We're going to start with just a quick overview of chemical reactions. A lot of this is going to be review of stuff that we've kind of intermixed throughout the whole year, as well as previous years. But more importantly, there's going to be a lot of different terms that come up over the course of these couple slides here. They are bolded. Keep track of them as we go through, because we'll be using them a lot, and we will want to be using them when we talk about chemical reactions as well. So we're going to start first and foremost with what a chemical reaction is. It's defined as any process that involves the rearrangement of bonds, whether those are covalent bonds or ionic bonds in a substance. And since this is happening, the result of a chemical reaction is always going to be making a new compound with a new chemical formula. Right? In some way, shape, or form that those chemical bonds are changing. It's different from a nuclear reaction because we're not changing any of the elements themselves. Right? The nucleus doesn't change. We're just talking about either the change of the way the covalent bonds are formed, so those would be the electrons being shared, or the change in ionic bonds due to the Coulombic attractions shifting around. This is different from a physical change because in a physical change, the element itself is not affected. If we had an example of water, right, H2O, we know that that is one oxygen bound to two different hydrogens. So if I had two water molecules here, relatively close to each other, we could maybe boil those and turn those into a gas and make them spread out really, really far from each other, move really, really fast. Right, but that is not a chemical reaction because at the end of this, we still have two water molecules. Right? Those didn't change in any way. However, if we were to take the water molecule and in some way break these hydrogens off of the oxygen and turn it into hydrogen gas and oxygen gas, that would be a chemical change because we now have a new substances at the end of this reaction. Right, so some examples of chemical reactions that we're familiar with would be things like rusting, burning, leaves changing color, baking, cooking of pretty much any kind is all chemical reactions. Whereas physical changes would be things like dissolving, crystallizing, phase changes, mixing things up without actually getting them to bond in a way, or coloring on paper. Noticing that we have color on both sides, it's really dependent on how the color is forming and happening in the change. Indicators that we can use to know that a chemical reaction is occurring and is not a physical change would be things like changing, obviously, in the properties of the compounds, but sometimes those are hard to measure. So things we can look for and observe would be things like the formation of bubbles and solids that weren't there to begin with. Also, the formation of water would be a chemical reaction as well, but it's hard to identify that sometimes when you have different solutions that look like water as well. Changes in energy, whether that's the release or absorption, or changes of color, all of those can indicate a chemical reaction. But often on their own, it's not enough to tell if a chemical reaction is happening. Usually we look for a couple of them together. For example, we just talked about in the previous example where a change of color could indicate a chemical or physical change. So usually we're looking for that along with something else. What some of those different signals can look like, just quick examples on the next couple slides. One example that came to mind for changes in properties would be like taking Elmer's glue, which we're all familiar with, and turning that into slime, where the appearance of it looks the same, but obviously the texture of it is different. It no longer dries to the point of sticking like glue. It can be stretched, molded, etc. Formation of gas can happen in a couple ways. We saw this, for example, in the metal reactivity lab where we had the bubbles forming on the metals in the acid or in the water. On the right here, we have a picture of Alka-Seltzer in water, which is more of an acid and base reaction, but that is also producing the gas in the solution. Sometimes we have a solid that forms seemingly out of nowhere. We started here in this example with two different clear solutions. Both of those contained a dissolved ionic compound, but when we put them together, we get this new yellow powder that ends up sinking to the bottom. This idea of something forming a solid and falling down is the definition of precipitate. Usually we think of precipitation as rain and snow, but in chemistry it's used to refer often to the formation of these kind of solids that sink to the bottom. The always exciting one is changes in energy. That could be a release of heat and light. For example, on the left we have the reaction of thermite. In the middle there we have the opposite where we have the absorption of heat with a rapid temperature change in just the span of a few seconds, causing the wet block to freeze to the beaker. And then on the right, we have an example of energy being released without it actually involving heat at all. That's examples of luminescence, so glow sticks, luminol, or in the top, even bioluminescence are all chemical reactions releasing light without heat. Changes in color. We have rusting example on the left there. We also see a new solid forming on the left there on the outside of the chain, but it also is a different color. Leaves and flowers changing color, blooming, all of those are chemical reactions as well. The leaf and flower petal colors are actually related to the acidity or basicity, the pH of the cells inside the leaf.